Alright, here's quiz 5, solutions for Math 251. In part 1 here, I give you 3 results. Well, we got the quotient rule, the derivative of log base b of x, and the derivative of arcsine, and I'm asking you to prove these using implicit differentiation. So the way you can do that with this first one is we can say, alright, let's think about this as maybe f over g. F and g are both functions of x here. And maybe we'll say y equals that. And what we'll try to do is find y prime, because if we can find y prime, that's the derivative of f over g. So that'll hopefully, when we find y prime, it'll give us this right here. And the way to get there is by first taking the natural log of both sides to use logarithmic differentiation. And now if you remember your log rules, the log of something divided by something, that's the same as the natural log of f minus the natural log of g. So what I have here is natural log of y equals natural log of f minus natural log of g. And from there I can take the derivative of both sides. So if I take the derivative of the left side, I got a chain rule here. Outside function is natural log of x. Inside function is y. So I get 1 over y prime using the chain rule. And taking the derivative of this right hand side here, I get 1 over f times f prime, because f is a function of x, so we're using the chain rule again. And then minus 1 over g times g prime. Let's move this back up here. And this is good. I want to find y prime. I have just one y prime in here, so I can multiply both sides of the equation by y. Actually, maybe before I do that, I'll note that y is equal to f over g. So 1 over y is g over f. And that's equal to f prime over f plus minus g prime over g. So really all I did is I substituted. I said y equals f over g, so 1 over y is g over f. So I changed this to a g over f right here. But the advantage of doing that is we're now pretty close to having the quotient rule, what we need. If you multiply both sides of this equation by f divided by g, we'll end up with just a y prime on the left. We're multiplying by the reciprocal. And we'll be left with f prime f over f g, because we multiplied this by f over g, minus f, I guess g prime f to keep it consistent, g prime f over g times g squared. And hopefully this mess right here is equal to the quotient rule. See, I think it is. We can cancel out these two f's right here and get f prime divided by g minus g prime f over g squared, which we can then make, kind of running out of room here, the quotient rule by finding a common denominator. Multiply this by g over g, and what you'll get is f prime g minus g prime f, and they both have the common denominator of g squared here. So using a little bit of shorthand notation, what we've done is prove this fact. We got the derivative y prime, where y is f over g. The derivative of f over g is equal to this thing right here. All right. Show that the derivative of log base b of x is equal to this mess right here. We're going to use a similar strategy. We're going to say, all right, y equals log base b of x. Let's try to find y prime. And, okay, we don't know the derivative of log base b of x. That's what we're asked to prove. So what we'll do is we'll try to get rid of this log base b of x. Since these things are equal, b to both sides of the equation are equal, but b to the log base b of x is just x. And the advantage of this form here is I know the derivative of both sides here. We know the derivative of b to the y is b to the y natural log of b times y prime. What I did there is I took advantage of the fact that the derivative of b to the x is b to the x natural log of b. But since our argument here is y, not x, and y itself is a function, what we have to use is implicit differentiation. What we have to use is the chain rule, and the inside function is the y here. Anyways, that's the left-hand side. Derivative of x is just 1. So if I solve for y prime, I get y prime is 1 divided by b to the y natural log of b, which is great, but it's not what I have up here. Actually, it is what I have up there, it just doesn't look like it right now. I know that b to the y is the same as x. So I can, instead of writing b to the y here, I can write x. And now what I have is exactly what I have right here. So what we've just done is prove that the derivative of log base b of x is 1 over x times natural log of b, using the fact that the derivative of b to the x is b to the x natural log of b. All right, third one. Give myself some extra room. This one's a little bit longer. Show that the derivative arcsine is this mess. Okay. Same strategy. That's that y equal arcsine of x. And let's try to find y prime. The way we do that, take sine of both sides. Sine of y equals x. The advantage now is we know the derivative of sine of y. Derivative of sine of x is cosine of x. So the derivative of sine of y is cosine of y times y prime. That's the chain rule in there. Derivative of x is just 1. So we get y prime is equal to 1 over cosine of y. Which is correct. That is the derivative, but it's not the form we want to show it in. First of all, it's weird to define the derivative of y in terms of y. So we should change that. Instead of writing y here, we can write arcsine of x. Let's say our derivative is the cosine of arcsine of x, which is also correct, but again, it's not equal to what we want it to be. It turns out that cosine of arcsine of x is the square root of 1 minus x squared, but we should probably show that. And the way we can do that is by giving this arcsine of x thing a name. Maybe we'll call arcsine of x, I don't know, t. And then we'll take the sine of both sides over here, and we'll say, all right, if arcsine of x equals t, then x is equal to sine of t. But let's see, what that's saying is that if I have some angle down here, t, the sine of this angle is equal to x. Well, sine is opposite over hypotenuse, if this is a right triangle here. SOHCAHTOA, if that helps you remember it. Opposite over hypotenuse has to equal x. So we can make this x and this 1. If you have this is x and this is 1, we can figure out what this angle is right here, or this side is. And you might be like, wait, why do you want to figure out what this side is? Well, because arcsine of x we said was t. So really our derivative is 1 over cosine of t. So if we can figure out cosine of t, we already have this picture here that has a t in it, we'll have our final answer. So the way we can do that is we can give it a name, maybe, I don't know, a. And we know that using Pythagorean's theorem, a squared plus x squared has to equal 1 squared. So that tells us that a has to equal 1, 1 squared is 1, minus x squared, square root of that. You don't need a plus or minus because we're talking about lengths here. So a is equal to this square root of 1 minus x squared because of this work I did down here. So my answer is 1 over cosine of t. Well, let's see, cosine of t, using SOHCAHTOA, cosine is adjacent over hypotenuse. So it's this divided by this. So my final answer is 1 divided by cosine, this over this. In other words, square root of 1 minus x squared. Square root of 1 minus x squared, which is exactly what we have up here. Awesome. So the derivative of arcsine is this thing. All right, now we got to do these. You only have to do 2 of these 3, but I'll do all 3 of them. This one you have some options on how you do it. You want to find dy dx. You want to find the derivative of y with respect to x. I guess the more straightforward way to do it is to be like, oh, I know the derivative of arcsine of x is 1 over the square root of 1 minus x squared. So I could say, all right, let's take the derivative of both sides. Derivative of arcsine is 1 divided by the square root of 1 minus, instead of x squared, my argument here is xy. Then you're not finished here. We're using the chain rule. We'll have to multiply times the derivative of x times y. Product rule there. You'll get derivative of x is 1 times y, plus leave the x alone and multiply it by derivative of y, which is y prime. So what we've done is taken the derivative of the left-hand side of the equation. On the right side, it's not as hard. Derivative of x squared is just 2x. Derivative of y squared is 2y times y prime. It's a chain rule. Outside functions x squared, inside functions y. Get this here. Whew. All right, so we have this mess, and what we want to do is factor out a y prime, get y primes all by itself. I think the easiest way to do that is to first distribute this through to both terms. So we get y divided by the square root of 1 minus xy plus xy prime divided by the square root of 1 minus xy equals 2x plus 2y prime. And now get all the terms with the y prime on the same side of the equation. Xy prime divided by square root of 1 minus xy minus 2y prime equals 2x minus y divided by square root of 1 minus xy. Now I can jump up here, factor out a y prime. You're left with x divided by square root of 1 minus xy minus 2y equals 2x minus y divided by square root of 1 minus xy. And then, I guess just divide both sides of the equation by all this mess on the left. That'll give you an improper fraction. So we could simplify. Maybe I will. We'll see. But it'll at least give us the right answer. So we're dividing both sides of the equation by this thing. So down on the bottom I have x divided by the square root of 1 minus xy minus 2y. So this right here is the answer. It's the correct answer. I guess I should reduce it. I don't really want to. But what we'd have to do is get a common denominator. Or you know what I can do? Multiply the top and the bottom of this equation by the square root of 1 minus xy. And what that will do is it'll cancel out this one, make one appear here and appear here. So we'll get 2x times the square root of 1 minus xy minus y divided by x minus 2y times the square root of 1 minus xy. So either one of those are fine. I don't really care if you simplify, but I guess I should set a good example. So what we get is the derivative, or dy dx in this case, let's label it, why not, is equal to this thing. Another option for doing this is you could start out by taking the sign of both sides of the equation. So maybe I'll write this somewhere. Or if we take the sign of both sides of the equation, we get xy equals sine of x squared plus y squared. That might be a little bit easier to deal with because the derivative of sine of x isn't quite as ugly as the derivative of arcsine of x. But you should get the same answer. It might not look identical. You might have to do a little simplification. But I imagine that way would be a little bit quicker. But I imagine most people will do it this way. All right. Derivative here. Let's see, we got some options. Okay, so one way to do it is just kind of put your head down and do the calculus. Take the derivative of both sides. Y prime on the left. On the right, derivative of natural log of x is 1 over x. So we get 1 over x squared y squared. Then we're not done. We have to chain rule, multiply by the derivative of the inside function here. Derivative of the inside function, we have to use the product rule. So it's 2x y squared plus derivative of 2, or y squared, is 2y y prime x squared. It's some mess like this. And so now we have the same general strategy. We want to get all the y primes alone on one side of the equation, factor one out and solve. So we could say y prime is equal to 2x y squared over x squared y squared. So what I'm doing is distributing this into both terms. Plus 2y y prime x squared over x squared y squared. If you want, you can cancel some stuff out at this step. Change colors to cancel. These y squareds cancel. One of these x's cancel. X squareds cancel. One of these y's cancel. So what we're left with is y prime is equal to, what, 2 over x 2y prime plus, is there nothing left on the bottom? No, there's still a y on the bottom. Hard to read my own writing. 2y prime divided by y. And now we want the y primes all alone. Y prime minus 2y prime over y is equal to 2 over x. Let's take this up here. factor out a y prime, you get 1 minus 2 over y is equal to 2 over x. Divide by this mess, you get y prime equals, yeah, I guess I'll make an improper fraction again, which we can then simplify. This is 2 over x divided by, this is y over y, so y minus 2 over y. And then if I invert this bottom fraction, if I multiply the top and the bottom by the reciprocal of the bottom, I get 2 over y x times y minus 2. So something like that. I guess at this point, well, yeah, let's just leave it there. So here's the derivative. This is the correct answer. Another way to do this, I don't really have room to show the whole way, but maybe I can at least, I'll do the same thing I did before. I'll circle it, and I'll say, or we could do e to both sides of the equation. We could say e to the y is equal to x squared y squared. Right, e to the natural log of something is that something. They're inverse functions. It might be easier to take the derivative of both sides there. Should get the same answer. Maybe I'll leave it at that. Whew, man, all right, and finally, this last guy here. Again, you got some options on how you do it. You could take the log of both sides, natural log, or log base 2. I guess you could take the arc sine of both sides, although I think that would get kind of messy. But I think I'll probably just plow right ahead and do it. The derivative of 2 to the x is 2 to the x natural log of 2. So the derivative of 2 to the xy is 2 to the xy natural log of 2 times the derivative of xy, which is y plus xy prime. So what I did here is I used the chain rule, and then when I had to take the derivative of the inside function, which was xy, I used the product rule. That's what I got here. And the derivative of sine of x is just cosine of x. So what I want to do is solve this thing for y prime. Just one y prime here, so maybe divide by all this mess and get y plus xy prime is equal to cosine of x, 2 to xy natural log of 2. And therefore, well, yeah, I guess I'll do 2 more steps. Subtract y from both sides. Xy prime equals cosine of x divided by 2 raised up to the xy power times the natural log of 2 minus y. And therefore, maybe instead of dividing by x, think about I'm multiplying both sides by 1 over x. And what I get is y prime is equal to cosine of x divided by x 2 to the xy natural log of 2 minus y over x. Multiplied 1 over x on both sides of the equation, and then distributed that 1 over x to both terms on the right-hand side of the equation. So a couple of these you could get different answers if you go through different steps in doing them. They should all, not different answers, different looking answers, but they should all be equivalent. But don't get freaked out if you got something a little bit different, but you might want to practice up some algebra skills and make sure that your answers are in fact equivalent to these. That's the end of this quiz.